PhD student here from the Industrial and Manufacturing Systems Engineering Department at K-State. And first, I would like to thank you everyone for being here, and thank you for the Pollution Prevention Institute and K-State for providing me with this great opportunity to show the work that we did this summer. So, like Linnell also said, I was a circuit rider. It's a different position than the other interns had this summer. I was based here in Manhattan, and I had the opportunity to visit 6 different facilities around Kansas, actually 5 companies and 2 city departments. We made 1 to 2 day site visits to each company, so it was a shorter experience at each individual facility than the other interns had. So we need to find opportunities to optimize the time available that we had to visit each company and find all the project opportunities, as many project opportunities we could to suggest them at the end of the program. So I had a total of 26 different projects evaluated throughout the 6 facilities. So to make it easier, I combined them into some main categories. So the projects approached quite a variety of different topics, such as hazardous waste reduction. We looked over ways to reduce water usage. We made some light audits, some air leak surveys. We evaluated the potential of using solar energy at the companies, and also heat recovery. So the first project, the first company I encountered this interesting project because they are an airplane parts manufacturer, and they were approaching a large quantity generator category, so they were worried about the amount of hazardous waste they were producing. And the major source of this waste was the almost 2 million Q-tips they were using per year, and the 12 tons of solvent. They were using mostly toluene-based solvent called Barso. And their process was pretty straightforward. They would pick up a Q-tip that was already soaked in an open container with Barso. They would swipe the part, clean the sealant that they were using between processes, and just throw it on the trash. So as you can see here, we have an open lead trash can with a bunch of Q-tips, and how they were arranging their workstation was basically having 1, maybe 2 buckets of Q-tips soaked in Barso. So in this project, we already found quite a few different opportunities to reduce the amount of waste they were producing. The first thing we observed was how long the handle was. So we checked on the OSHA regulations if there was no specific guideline about the length of the handle. So the first thing suggested was basically reducing the handle size. And also when we observed the buckets, we noticed how the wooden handles was also absorbing moisture from the solvent. So we were able to actually measure how much solvent it was absorbing through a little experiment. So this was also a source of waste because we just need the solvent to be at the cotton tip to be cleaning the part. So this was another suggestion, and to do that, we also considered the fact that the buckets were open containers, and it was also causing a lot of evaporation of the solvent. So by changing the buckets to plunger cans, we would have closed containers, and we would also change the process a little bit, so then the Q-tips wouldn't be soaking all day in the solvent. So by doing this alteration, the yearly impacts expected was to reduce about 1,400 pounds of hazardous waste, and we could actually figure out using some open vessel evaporation models to find how much solvent was evaporating throughout the year. And also we noticed how repetitive and not ergonomically appropriate the hand tool was, because they were using a precision grip that requires actually a much larger diameter, so it wouldn't really hurt your hands while doing this job. So we we actually propose that this full task should be redesigned and they can think about other alternatives to reduce even more the waste. But these were simple alternatives to improve their process. And also, since we were changing the actual task, how the process would work, we also evaluated how much more time the employees would take to do the task in a different way. So we did a time study to evaluate how much more time it would take. And for an average of 1,000 Q-tips they were using daily, it would increase about 12 minutes their work activities. Another problem encountered was with expired sealants. So the same company, they have this sealant that they use in their parts, and it has a shelf life of approximately 4 weeks, and the lead time to deliver this sealant was about 2 weeks. So it left the company with only 2 weeks to use that sealant, otherwise it would expire. And since it is an airplane parts manufacturer, they are really, really strict with expiration dates. So it would go to the trash. So we found a simple opportunity of just implementing first in, first out systems because employees were checking out sealant bags from the main inventory area and storing it in some intermediate freezers around the facility. And they were getting a little bit confused with it. Sometimes two people would actually check out the same sealant type bag. They would have much more than they needed. They were purchasing more sealant. And they were not necessarily selecting the oldest sealant first. So this was generating a lot of waste. So in 1 month, they actually lost almost $40,000 just with expired sealants that could be easily reduced just by implementing simple policies such as using FIFO systems. So in all companies, the first thing we did was basically figuring out what type of chemicals they were using, and we did a chemical analysis on them and tried to find possible replacements. We were always aiming to reduce volatile organic components, hazardous added pollutants, and we were specifically looking for Toxic Substance Control Act chemicals, and most specifically the 2014 Act. And we found a lot of toluene being used, xylene, and MDI-based paints that we were trying to replace or look for less hazardous types of materials that could actually perform the same way that those were. So we look for ideas on how to reduce solvent. So one major idea was simple as standardization of processes. So there was this company that had a big variety of primers they were offering to their customers that they really didn't know that much about the primer, and it wasn't really making that big of a difference. But when they were painting the parts, they would have to clean the lines each time that they were changing the primer. And this generates not only solvent waste because they need to clean the lines, but also a lot of paint waste because they need to bleed the line right after they finish painting. So standardizing is a simple procedure that they can use, and it was proposed to one of the companies. We noticed that some companies were already recycling solvent and some of them were not, so we recommended recycling the solvent, even though it's not officially P2, but they were just reducing the amount of solvent they were purchasing and also disposal costs. And we were also aiming to reduce waste from evaporation by using closed systems, keeping all solvent containers always closed. And we were able to reduce about 15 tons of VOCs, 3.7 tons of HAPs, and about $30,000 in savings. From paint and solvent replacements, so we always look for lower hazardous paints, and we try to make recommendations using a UK software called Paris 3. So we look for possible solvent replacements that could achieve the same that could have the same physical properties as the one that we were using. So we mostly made acetone recommendations for them because acetone is a VOC exempt component and not HAP. So using that, we were able to reduce 18 tons of HAPs and about 200 gallons of paint and 600 gallons of salt. Another opportunity was about training painters. So even though you're already using HVLP guns, you can save almost double the savings if you train those painters, and you can increase the efficiency from about 45% to about 65% with the lead painter training. So we also recommended that for the company because their lead painter was not trained. And then moving on to another major category, the air leak surveys. So compressed air is one of the most costly utilities we have in our plant today. They can be they can be not efficient at all, as low as 10 to 50% efficiency in their systems. And leaks are not only a waste of energy, but they also generate emissions, and they decrease the efficiency, the overall efficiency of the company, and reduce the quality control, because we might expect to have a specific pressure at a gun, and you're actually not achieving that because you have a leak in the middle of the way. So using the same equipment that Kaylin used, the Ultra Pro 9000, we were able to make 4 different surveys. Small surveys, actually. The full survey requires sometimes much more time, and you need to go on a ladder to reach all the pipelines. But we did a small survey with the frequency set to 40 hertz. And we found, so the first thing was finding the air compressor set PSI. And then we searched for leaks around the facility, and using the app, we collected how many decibels the leak was producing, so we can estimate cost savings after fixing those leaks. So we also found one implemented project from a previous intern, and we had a total of 589,000 kilowatt hours and about $79,000 in savings if those leaks are fixed. So another category was regarding light audits. So we were recommending companies to switch to LED lighting. LEDs are known for being much more energy efficient, so you can emit much more lumens per watt. And this actually represents less energy cost for the company. Since they are more efficient, they produce much less heat, and much less heat will cause less cooling costs for the company. LEDs have no hazardous materials such as mercury, so we have less disposable costs for the company. Normal fluorescent tubes, they have a beam angle of 360 degrees, so we need to rely on the fixture to direct the light to the place that we want it to be directed. And LEDs have a much smaller beam angle, so we have much more direct lighting, meaning that we need less lumens on the tube to get the amount of illumination that we need on the surface. And they are also 66% more durable than fluorescent tubes. So this means that the companies will have less purchasing and labor costs to get those lights and then to replace them. So the process was pretty straightforward. The first thing we asked for their energy bills to see how much they were paying for their energy. We made an inventory of the lights, so we counted the lights at the facility, and then we looked for the appropriate replacements for those lights, considering the amount of lumens that each workstation requires, considering the temperature that the company wanted or needed the light to be, and the type of fixture that they were using. So we had to check if they were using ballast or electronic or magnetic ballasts. So with that information, we were able to estimate costs and savings. We did this light survey in 2 different companies, and the estimated savings were of 117,000 kilowatt hour, or about $30,000 in savings. A different project that I approached was for the city department. So we went to an aquatic center, and they wanted us to basically reduce their environmental impact of their systems, their current systems. They already had implemented LED lighting. So we looked at their overall pool system. And some of the opportunities found were relating to heat recovery from boilers. So using the blow down energy of the boilers, can generate from 0.3 to 2% in savings of natural gas. Another different alternative, they were already using the systems to clean the water. So a relatively new system that they have available right now is hydroxyl-based advanced oxidation process. So the system basically takes ambient air, it converts to atomic oxygen, and it injects this oxygen in the system. It creates hydroxyl radicals that basically destroy the bacteria and the unwanted chemicals on the water. So they have some case studies that reduce the chlorine by using this methodology by 30 to 50%, and this department was using more than 10,000 pounds of chlorine per season. So this can reduce the amount of chlorine required considerably. It is still a pretty expensive system, so in terms of cost and savings, it was not really that good analysis, but we let them as a project that requires further research. Full cover could actually reduce the amount of water evaporated. And another thing was solar heaters. So instead of heating the water using a normal boiler, you can actually use solar heat, and it works basically like solar panels. So you have solar collectors that you have on the roof of your building. It heats the water, and we know that Kansas is a really sunny and warm state, so we can definitely take advantage of this this weather that we have here, and we can generate from 4 to 10 months of warm water yearly. So we simulated, they currently have 3 boilers, so we simulated not using 2 of their boilers for 6 months every year. And again, not necessarily a solar heater, but we also suggested solar panels just because we should take advantage of the weather that we have here. We have a lot of solar potential, so companies can implement solar panels. The cost is decreasing throughout the years, so it is becoming very feasible. We have paybacks of about 7 years, just like we saw, and a lot of government incentives. So it's a feasible project that is really good for the environment and the company. Even though HVLP guns are already more effective than non-HVLP guns, they are still only reaching a transfer efficiency of about 65%. So we recommended companies to look over different methodologies that can reach higher levels of efficiency, such as powder coating. It would require a full redesign of the layout of the facility because you need to have an oven to cure the parts. But it is still something that a lot of companies have been applying and getting really awesome results. Another thing was about water-based fans, and it has the same problem because dry time is much longer than traditional paint, so they would have to redesign their layout, but it is a much more environmental friendly approach for paint. So the summary for the projects, I tried to combine them into some main categories. So we have the air leak audits, the solvent intake replacement and reductions, some additional material replacement and reductions that we found the opportunity but needs further research. The carbon tips waste reduction that we could reduce more than 1,000 pounds of solid waste, the LED replacements, and the solar heater that can reduce a lot of natural gas usage. So for the totals we have here, the total greenhouse gases reductions was from 1,578 metric tons of CO2. So thank you everyone, and now if you have any questions, I'll be happy to.
I had a question about the hydroxyl-based advanced oxidation process. Does it have good efficacy on Giardia and Cryptosporidium? The bacteria, the Cryptosporidium, and
yes,
it does?
Yes. So they said that this has been a really good they have a case study where they basically got rid of all unwanted bacteria. So it is very similar to the UV systems, but it uses less energy. But the thing is that the full system right now is more expensive than the UV lighting. And the UV lighting not necessarily reduces the amount of fluorine you need.
Hey, great presentation, and you worked with so many different projects, and just hearing you present it, obviously you had a really good grip on many aspects of them. So I'm quite impressed with, you know, the fact that you know about hazardous air pollutants and VOCs and just several things that you did there. So really good job. I was curious on that pool. Was that a year-round pool? Is that why you were basing 6 only, you know, 4, or is it only open? Is it an outdoor pool?
So I considered the 6 months because technically we cannot really use the sun to heat the water during the winter. We couldn't really reach the efficiency of a boiler. So that's why I considered the 6 months to do the calculations, to be a little bit more conservative on the numbers. But I think it works, at least the indoor one. The outdoor probably closes during the winter. But the indoor center, it has AC inside, so they have an Olympic size pool that people make competitions throughout the year. So that the indoor center, it works, but the outdoor, it doesn't.
Okay, and then back to your final chart. Does that, and I know we're not using company names here, and the whole idea, just for folks who may not know, with the circuit rider is that we do a snapshot visit, and that hopefully next year the companies will want to hire a full-time intern to work on possibly further research on these projects, but other projects too. So that's kind of that whole idea of this. But I was curious, not naming the company, the Southeast Kansas company that we worked with, is their data reflected in here? They had already implemented several things, and some of them were previous and some of them were just within this time period.
So here we have the
paint
audits where we have recommended / implemented. So
that was on air leaks. Okay,
yeah.
So we had all that paint data too. But we can talk about that later. I was just seeing if I wanted to make sure we capture all those savings.
Yeah, I think the only data I have in this summary from that company is regarding the air leak.
Okay.
That they already implemented.
Okay, great. We'll follow up on that one then. Thank you.
So Chris, regarding the pool, you said they do water harvesting, or
No, they don't.
they don't, so
They
I
don't.
would suggest that as well.
Yeah, so it is a possibility to suggest that they use water harvesting. We would have to estimate how much chemicals we would require to treat the water to see if it would benefit to have this system implemented. But they really don't care that much about capturing water because since they're a city department, they don't pay for water. So they weren't really, I actually asked for belts and they just told me we don't have any. So, but this is, but this was something that we could definitely estimate.
And what would have been your favorite project that you worked on?
I think the first one that I presented, the parcel, I think the idea of, because I had to check the full task, how they were using, how they were actually performing the activity, and they were having a lot of problems in terms of health of their employees, because I think 3 employees already had carpal tunnel syndrome because of that very repetitive tasks. So working on that specific project, I think it was interesting because it could combine a lot of different knowledge that I gained so far here in engineering school. So doing time studies, actually finding the evaporation rates from the open vessels and making experiment to figure out how much solvent the wooden handle was absorbing, so I had to find a precision scale to do all the measurements. So it was very fun to do the whole project and actually get the final number. So this is the amount of bar so they can say. So I think that this was right.
Plus the ergonomics.
Yes.
Cool. That's great. That's great.